In this problem, we're asked to solve, remembering that factoring doesn't always work, but when it works, solving is the easiest using the factoring method, in my opinion. Quadratic formula and completing the square always work, and I'm actually going to demonstrate to do all three. You don't have to use all three methods for the test, but I do want to show you how this works. So let's start with factoring. Is this factorable? Remember, it only sometimes works. Now, a confusion some students have had is that, if I can't factor, does that mean I can't find the answers? No, that's not the case. It's just this particular method sometimes works where these always work. So these just take a little bit more time to process. They're sometimes a little more difficult for students, but they will always work. Remember, I will not be providing you the quadratic formula. That has to be memorized on the test. Okay, factoring. How do I do this? So for factoring, I ask myself, 1 times 17. Am I able to come up with two numbers that multiply to give you 17 and combine to give us 10? Well, 1 and 17 is a prime number. Those are the only two combinations of two numbers that multiply to give you 10 integers, and they don't give you, that multiply to give you 17, but they don't equal 10 when you combine them. That means factoring for this is not an option. So I'm going to move on to the quadratic formula, and then also to completing the square. You choose which one you prefer. So in this problem, A is 1, B is 10, and C is 17. This is the quadratic formula. I'm going to replace B with 10, make sure that it always goes inside parentheses. Here's a negative 10 plus or minus. I know 10 squared is 100. Okay, 4 times 1 is 4. And 4 times 17, you could use Desmos or calculator on your computer, is 68. So subtract 68 all over 2. Remember, this extends over the entire problem on the right-hand side. Okay, what is 100 minus 68? Well, if I take 68 away from 100, I end up with 32. Excuse me, that should have been plus or minus. 10 plus or minus the square root of 32 all over 2. Now 32, let's think of all the numbers that are perfect squares up to 32. 1, 4, 9, 16, 25, 36. 32 is right here. So we need to ask ourselves, are any of these numbers other than 1, that doesn't reduce anything, can I divide any one of these numbers into 32 and get a nice integer answer? So start with the largest. 32 divided by 25, that doesn't give me an integer answer. 32 divided by 16, it does. 16 times 2 is 32, so I can rewrite this. X equals negative 10 plus or minus. 32 is 16 times 2 all over 2. I know the square root of 16 is 2. Is 4, and then I have the square root of 2. Now this has to be shared with both the left and the right, so x equals negative 10 over 2 plus 4 over 2. X equals negative 5 plus or minus 2 square roots of 2. This would be our final answer. Now I'm going to show you how to do. So you have to use quadratic formula? No, you can use completing the square. It's your preference. I start by moving the constant, the number without the x, to the opposite side. When it crosses over the equal sign, it changes signs. And I'm just going to do this just because I've continued teaching you with kind of a row so it shows up. It's nice because the leading coefficient is 1, so I don't have to divide out by 1. I take what that b value is and I divide it by 2. Then I square that value, and 5 squared is a positive 25. And since there's only a 1 here, 1 times 25 still gives us a 25. Then in parentheses, whatever this is goes right here, x plus 5 quantity squared. And I do the math. 0 subtract 17 plus 25. 0 subtract 17 plus 25 is an answer of 8. And I'm solving for x. So I start by getting rid of this square. Remember, this tells us I'm going to have two answers. How do I get the two answers? Plus or minus the square root of 8. I'm going to reduce that after a while. I moved the 5 to the opposite side by subtracting. Remember, it moves across the equal sign. It changes signs when you're adding or subtracting. And now it's a perfect square, so I write down all the numbers up to 8. 8 would fall in between 4 and 9. And so I'm working backwards. Can I take any one of these numbers to the left and divide it by 8 and get an integer answer? So I know 8 divided by 4 is 2. Square root of 4 is 2. And here's the exact same answer using the completing the square method.